and you can get monosaccharides. Lipids, because they're hydrophobic and they don't dissolve in water, how do you attack them? How do you break them down? That calls for the action of a helper agent in the form of emulsifiers. Should I get up? That are known as bile salts. You can just look at this and know where it comes from. These are derivatives of cholesterol, yes. One of the many functions of cholesterol in our body. In fact, the bulk of our metabolism of cholesterol is to convert it to this stuff. You add on these groups, notice there's a carboxylic acid here, a couple extra hydroxyl groups. Makes it a little bit more polar. Originally, cholesterol would just have this one hydroxyl group here, but the liver does this kind of modification to it, and it gets secreted into the small intestine to help emulsify the otherwise insoluble fat droplets. So if you were just kind of grossly characterized this as hydrophobic and hydrophilic, there's a few hydrophilic groups that are kind of pointing down here on one side, and then the other face is hydrophobic. That's amphipathic. That's exactly the kind of thing that would have something like a detergent action, basically. It has a hydrophobic, hydrophilic side. And you can stick these things on a fat globule, a bunch of neutral triglycerides that are water insoluble, coat them with these bile salts, it solubilizes them. So you can get really small droplets of these things. And that makes a suitable substrate for the digestive enzyme, hydrolytic enzyme, lipase. This is the enzyme that comes in and clips off the free fatty acids.